You know, in the world of software, some ideas are so fundamental, they're basically like the laws of physics. Today, we're digging into the wisdom of the legends who figured out those laws. We're going way beyond just syntax and diving straight into the philosophy of code, the core principles that really separate the good programmers from the truly great ones.
It's a question every single one of us asks at some point. What's the real difference maker? Is it how fast you can type, knowing every obscure algorithm by heart? Or is it the number of languages you can list on your resume? Well, the answer, it's probably not what you're thinking.
See, the real difference isn't about what you know, but how you think. It's about being able to find clarity in the middle of chaos, to explain complex ideas in simple terms, and to build things that are actually meant to last. And the best part is, the pioneers of our field left us a roadmap, a whole set of truths that can guide this way of thinking.
All right, so let's get into that roadmap. This is what I mean by the philosophy of code. These are foundational ideas that are just as relevant today as they were the moment they were first written down.
Every great developer's journey really starts at the exact same place, learning the craft of writing clean code. It is the absolute foundation for everything else you're going to build. Code that's clear, simple, and written for another human being to understand.
It's so tempting, right? To build these super complex systems to show off how smart you are. But this quote gets to a much deeper truth. Great engineers literally fight for simplicity. Why? Because simple code isn't just easier to maintain, it's almost always faster. It has fewer bugs, and it lets the whole team move way, way faster.
Oh man, this one just nails it. It perfectly identifies who your code's real audience is. Look, a computer will execute pretty much anything you throw at it, gibberish or not. But the real user is the next developer down the line. Or, let's be honest, it's you 6 months from now, who has to figure out what on earth you were thinking. Your code is a message to another person. Period. And you can see it right here. On the left, you've got a tangled mess. On the right, a clear path. Now, both of these might actually work, but only one of them is valuable to a team. The clean version isn't just about looking pretty. It is a massive strategic advantage. It cuts down on bugs, it speeds up development, and most importantly, it lowers the cognitive load for everyone, which frees up precious brain power for solving the real problems. Okay, this is such a timeless warning against writing clever code. You know that brilliant, super condensed one-liner? It feels amazing to write, I get it, but it becomes an absolute nightmare to debug later. Like the quote says, if you write code at the absolute peak of your cleverness, you've left yourself zero mental runway to figure it out when, not if, it breaks. The lesson is simple. Clarity will always, always be cleverness. So, clean code is the goal. But what's the process actually like? Well, that brings us to the daily grind. This is the reality of a developer's work, which is often less about perfect, elegant design and more about just navigating the messy, unavoidable problems that pop up when you're building stuff.
It's really easy to see bugs as personal failures, but this quote reframes that idea perfectly. I mean, think about it. If programming is the act of building, then bugs are just the sawdust. They're an inevitable byproduct of creating something new. The mark of a great engineer isn't that they never create bugs, it's that they've mastered the process of finding and fixing them systematically.
And here it is. This is probably one of the most famous principles in all of software engineering. We so often try to guess where the performance bottlenecks are going to be in our code, and we are almost always wrong. Wasting time optimizing code that isn't actually slow just adds a ton of complexity for literally no gain.
And this chart shows you exactly why. In most applications, a tiny fraction of the code, that's your hotspot, is responsible for the vast majority of the execution time. So Knuth's wisdom here is simple. First, just get the program working correctly. Then, use tools to actually measure and find that 10%, and only then do you go in and optimize that specific part.
All right, get ready for this next one. It's a classic piece of industry humor, but it is packed with such a deep truth that pretty much every developer feels it in their bones.
And there you have it. Cache invalidation, famously a deeply complex technical problem. But naming things, it sounds so trivial, right? But it's hard for a really profound reason. To name something well, you have to understand it perfectly. A good name isn't just a label. It's like a compressed form of documentation that instantly reveals purpose and context.
So all of these principles, they lead us to the final stage of mastery, the mindset. This is where we start scaling our thinking from just lines of code to entire systems, and from working on a single project to building a career of continuous learning.
Look, any system that's successful is going to grow, and with that growth comes complexity.
This quote just nails the true job of a senior engineer. You're not just a feature factory cranking out code. Your primary role is to be a complexity manager, using smart architecture and solid design to keep the system understandable as it scales.
And finally, a lesson in humility and good old-fashioned hard work from one of the creators of C and Unix. You can read all the books you want, you can watch every tutorial online, but true mastery only comes from one thing: practice. Real understanding is built by doing the thing, failing, and then trying it again.
So, after all that, what do all these insights really add up to? Let's try to pull it all together into just a few timeless lessons that truly define the craft of building software.
A great programmer does so much more than just write code. They are thinkers who can turn ambiguity into clarity. They're kind of like artists who find that simple, elegant solution hidden inside a really complex problem. And maybe above all else, they are lifelong learners, just relentlessly curious in a field that is never, ever going to stand still.
And that's really the big takeaway here. These aren't just clever phrases to put up on a motivational poster. They are practical, actionable principles that you can use every single day to write better code, build better systems, and ultimately become a better engineer. So I'll leave you with this one question to think about. Whether it's making simplicity a priority, or focusing on your code's readability, or maybe finally learning that new language hands-on, which one of these principles will you consciously try to apply to your work tomorrow? Thanks for watching.